Okay, so let us look into the reaction of propine. So propine, which is subjected to hydrolysis process. So when this propine is subjected to hydrolysis process in the presence of dilute sulfuric acid and mercuric sulfate, so then we get the unstable product is so unstable product we'll get, that is CH3 COH double bond CH2. So this is alcohol we get, which is unstable, and this unstable alcohol subjected to rearrangement process by the tautomerism, and it can give rise to the product is carbonyl compound we get the carbonyl compound, that is a ketone is obtained. So the ketone CH3C double bond OCH3 we get in this reaction. That means simple, when alkyne substances or alkyne hydrocarbons subjected to hydrolysis, so acidic hydrolysis, we get the carbonyl compounds. Ketone we say propine is changed to what means into the carbonyl compound. Okay, so how this mechanism goes? Now let us look into this mechanism of the reaction. So what mechanism is involved in this reaction we can see. As you know that in acidic solution there are mercuric ions are present. The mercuric ions are present, Hg plus 2 ions are present in the solution of the reagent. Where there is a mercuric ions approaching this triple bond, this mercuric ions causes bond polarization. See here R value represent, and this R value represent CH3. This R value represent this R value is represent what we call means CH3 methyl group, CH3 C triple bond CH. When this mercuric ion interacting with this triple covalent bond, so and causes polarization, then it make bond with these two carbons it will make, since the mercury is divalent cation, and it is making two bonds with this carbon. And so when after this next step, this is the intermediate compound substituted compound, this is mercury substituted compound. So when this compound is interact with the water, then water behave like nucleophile, and it donate the lone pair of electrons to this carbon. So when the lone pair is given to this carbon, then this bond is broken between mercury and carbon. So then afterwards the charge decreases, mercury charge decreases, so +1, and this nucleophile is attached to this carbon. As a nucleophile means water behaving like water is behaving like nucleophile H2O. You can see the structure of this H2O. Oxygen consisting of two lone pair of electrons, and so oxygen in that water molecule, lone pair of electrons are present. One lone pair is given to make the bond with the carbon, then oxygen get the positive charge. When oxygen get the positive charge, in order to compensate this positive charge, oxygen, this sigma bond is converted into lone pair, then proton is last. That means the water loses the proton here. You can see, look at this. So water loses the proton, then OH, this OH is added to this carbon. Now look at this carbon holding that OH, and mercurous ion is present here. Then this molecule CH3COH double bond CH mercury, this compound undergo keto-enol tautomerism. So keto-enol tautomerism. So what is a keto-enol tautomerism means? In this keto-enol tautomerism, alcohol functional group changes into ketone, and ketone functional group changes into alcohol. That means OH functional group is said to be enol, and C double bond O is said to be ketone, right? That means how this tautomerism takes place. Let us look into this. Since the mercury still carrying the positive charge, there is a pi bond shift between this mercury and carbon. Then this carbon gets the positive charge. So when the carbon gets the positive charge, this lone pair electrons will move here between oxygen and carbon. When the lone pair electrons moving between oxygen and carbon, then the positive charge shifting to where means to the oxygen. When oxygen make double bond with this carbon, this proton, means the carbon loses this proton, oxygen loses this proton is lost. So this proton will be moving to this carbon. Since this carbon getting the negative charge, so this proton will be moving to this carbon. Since this carbon getting the negative charge, so where the mercury ion will be released, so then it is the ketone double bond is formed between oxygen and carbon. Then so departure of this oxygen, mercury ion will be removed. Mercury ion is removed, so then hydrogen will be, means that hydrogen is shifted to this. So then what compound we can get? Means, so this is the ketone we get. Ketone form we can get. So, and the ketone form accept the proton from the acidic medium, again changes into alcohol form and loses the proton, then ketone form. Keto-enol tautomerism. This is what we call keto-enol tautomerism. We say keto-enol tautomerism. We call this is. So keto-enol tautomerism includes the proton shift. So similar to this mechanism, there is hydration of alkenes. So addition of water molecules. Addition of water molecule to this alkyne group, so that is called hydration of alkynes, we say. So when water molecule is added to this triple bond, so what happened we see, and in this mechanism, hydration of alkynes, propane will take step 1, enol formation. And in this enol formation, so now let us observe this. There is so water, in acidified water, there is hydronium ion are present. Hydronium ions are present more in acidified water. This is hydronium ion structure. So OH2, OH3 plus. So when this hydronium ion interacting with the triple bond, so see what happened. You can see now. The double bond is given to this proton, and the sigma bond is moving on to this oxygen. As a result of this, so that means here one carbon get positive charge, other carbon get negative charge. That means here this is electrophile reagent, polarize this bond, polarize the double bond, triple covalent bond. So when this hydronium electrophile, when this electrophile approaches, there is a bond polarization. The pi bond electrons are given to this proton. When the pi bond electrons are given to this proton, then bond is made between this carbon and hydrogen. So when the bond is made between this carbon and hydrogen, there is a means electron deficit on the next carbon, positive charge here. So this carbon, sorry, here we can see here there is a positive charge. The carbon get the positive charge here, and hydrogen will make bond here. Now, when the carbon get positive charge here, so from the water behave like nucleophile since carrying the lone pair of electrons. On oxygen, water act as a nucleophile and giving lone pair of electrons to this carbon. When the lone pair electrons is given to this carbon, then water molecule bond is made between this carbon and this oxygen. Since the lone pair electron is consumed for making bond, on oxygen we can see that positive charge, electrophilicity charge is formed. And in order to neutralize this positive charge, one of that hydrogen and oxygen bond is sigma bond is sacrificing to form this lone pair. Then the proton is lost. So this proton is given to the water to form hydronium ion. So next, so when this proton is lost, then OH is formed here. Then and it is formed enol form. Enol form means CH3 COH double bond CH2 enol form is produced here. When this enol form is produced, this compound enol form, it undergo tautomerism. When it undergo tautomerism, look at this. So how this tautomerism takes place. So when this enol form interacts with the water molecule, means acidified water, hydronium ion. So the double bond is means pi electrons are given to this hydrogen. When the double bond is given to this hydrogen, means proton, there is a bond breaking between this oxygen and hydrogen. So then this will become water molecule. The proton is added to this carbon. And when the proton is added to this carbon here, then there is a positive charge. Here we could see the positive charge. Because when this pi bond is given to this hydrogen, there could be positive charge here. Then in order to neutralize this positive charge, the lone pair electrons come between this oxygen and carbon. Then double bond is formed here. When double bond is formed between oxygen and carbon, there is a positive charge is being formed at that oxygen. So, and in order to compensate this positive charge, the lone pair is, or the sigma bond is converted to lone pair, then proton is lost. This proton will be taken by this water to form hydronium ion again, to form hydronium ion. So that means this is the structure again will form hydronium ion. Hydronium ion is the, so acid, hydronium. So here is hydronium ion is formed. Hydronium ion is formed here. So then the final product will be, so final product is a ketone. The ketone is prepared. That is called propanone is formed. Ketone is formed here. So finally, what we can tell from this mechanism is that when the alkynes are subject to hydration, so the step 1 will be enol formation. Enol formation, we can see the step 2 is tautomerism. So tautomerism is the step 2. Tautomerism we say. So that means 2 steps are present is enol formation, alcohol formation with a double bond. And the proton shift, there is a proton shift takes place. When proton shift takes place from alcohol to this carbon, proton shift, this proton is shifted to this carbon. So proton shift takes place in that. So this proton shift changing from oxygen to the carbon within the molecule, the proton shift. So then it is said to be tautomerization. Tautomerization we call this is. As a result of this tautomerization, we can get carbonyl compound that is called ketone we can prepare, that is called propanone is prepared by this mechanism hydration of alkynes. That means when alkynes are subjected to hydration with the acidified water, we can get the carbonyl compounds, ketones and aldehydes we get. So this is the mechanism of the reaction of alkynes. Next reaction of alkynes is that, so very important reaction or polymerization. As you know that polymerization is the process of joining of the monomers, joining of the small molecules to get a long chain of molecules is called polymerization under suitable conditions. So what is meant by polymerization means the polymerization is the process of joining the monomers, small molecules into long chain of molecules called polymers. To get polymers is to be polymerization. And in this polymerization, there are two types of polymerization. One is linear polymerization. So one is what we call means linear polymerization. We say linear polymerization, right? And another one is cyclic polymerization. So what is a linear polymerization? Already we discussed about that polymerization in alkenes. So under suitable conditions, the linear polymerization of ethane takes place to produce polyacetylene or polyethane, which is a high molecular weight, so polyene compound containing repeating units of CH double bond CH, CH double bond CH, and can be represented as so CH double bond CH, CH double bond CH. Under special conditions, this polymer conduct electricity. The very important thing here we have to discuss is about the polymers of ethane. The polymers of alkynes have the so semiconducting property or conducting electricity property. The thin film of polyacetylene can be used as electrodes in batteries. So that is the advantages of linear polymerization. If you take the so ethane, for example, if you take ethane molecule consisting of triple covalent bond. Triple covalent bond. So when these ethane molecules are subjected to polymerization, these pi bond electrons are used to link that so molecules, small molecules to form long chain of molecules. This pi bond can help to form that or to link the monomers to form the polymers. So another cyclic polymerization, next another polymerization of alkynes is that cyclic polymerization. In this cyclic polymerization, ethyl molecules when passed through the red hot iron tube at 873 Kelvin temperature undergo cyclic polymerization. That means in three molecules will polymerize to form the benzene. So and in order to prepare the aromatic compounds we use so ethane otherwise called acetylene C2H2, three molecules pass it through this red iron tube at 7 means the temperature is 873 Kelvin temperature, then we can get the benzene structure we can get. So look at this reaction, three molecules of ethane. So this is 1, 2, 3 molecules, between them carbon-carbon triple bond is there. Then when these pi electrons are polarizing, this carbon get positive charge, this carbon get negative charge. So negative charge carbon attack the positive charge carbon, then negative charge of this carbon attack this positive charge of the carbon, this negative charge attack this positive charge of the carbon. So here is the negative charge, here will be the positive charge. And here is the so negative charge and here will be the positive charge. Here is the negative and here is the positive. So As a result of this, we can get benzene structure. We can get the benzene structure aromatic compound. That means so alkynes so converted into aromatic compound like benzene. So this is since so linear molecules are joining together and forming into cyclic compound. Hence, this is said to be what we call means cyclic polymerization. We call this is the cyclic polymerization. The cyclic polymerization. In this cyclic polymerization, so 3 moles of or 3 molecules of ethane converted into